liftoff on Apollo 11.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground.
Armstrong is on the moon. Neil Armstrong.
Integrated circuit, also called microelectronic circuit, microchip, or chip. An assembly of electronic components fabricated as a single unit in which miniaturized active devices and passive devices. And their interconnections are built up on a thin substrate of semiconductor material like silicon. The resulting circuit is thus a small monolithic chip which may be small as a few square centimeters or only a few square millimeters. The individual circuit components are generally microscopic in size. An integrated circuit can function as an amplifier, oscillator, timer, microprocessor, or even a computer memory. An IC is a small wafer, usually made of silicon, that can hold anywhere from hundreds to millions of transistors, resistors, and capacitors. These extremely small electronics can perform calculations and store data using either digital or analog technology. The integrated circuits became the essential piece of technology that ultimately empowered the United States to achieve a man can go in the moon in 1969. So now let's discuss the history of integrated circuits. The first revolution of integrated circuits can be tracked back approximately 100 years ago. John Fleming invented the vacuum tube in 1904. He was an English electrical engineer and physicist known primarily for inventing the first vacuum tube. It was also called a thermiomic bulb, vacuum diode, Kenotron, thermiomic tube, or Fleming bulb. This invention is often considered to have been the beginning of electronics, for this was the first vacuum tube. Fleming's diode was used in radio receivers and radars for many decades afterwards, until it was superseded by the solid-state electronic technology more than 50 years later. The first transistor invented in 1947 by the three American physicists to replace the cumbersome vacuum tube. These things were the fraction of the size of a vacuum tube, used way less power and didn't break nearly as much. And if you combined a bunch of these transistors together, we can get an integrated circuit. Jack Kilby began his career at Texas Instruments in 1958, where he went on to invent arguably the most important invention of the 20th century, the integrated circuit, or also known as the microchip. There was a problem of numbers. Advanced circuits contained so many components and connections that they were virtually impossible to build. Then, he found a solution to this problem. Kilby's idea was to make all the components and the chip out of the same block of semiconductor material. This prototype is the first working integrated circuit on germanium. It has a transistor attached to two gold wires and a capacitor. The germanium itself, secured on a glass slide, is divided into three resistors by the tabs at the bottom. By showing that all the three types of components could work in the same slice of germanium, Kilby offered a way to improve the performance and the lower cost of the electronic devices. Robert Noyce further develops the IC chip. He solved several practical problems that Kilby's circuit had, mainly the problem of interconnecting all the components on the chip. This was done by adding the metal as a final layer and then removing some of it so that the wires needed to connect the components were formed. It was announced in 1961 that the resistor-transistor logic chip was one of the first commercial integrated circuits. It has 4 transistors. The white lines are the metal traces which connects the transistors to the 2 resistors below. The Apollo guidance computer used the chip. Microprocessors were invented in 1971 by Ted Hoff, along with a handful of visionary colleagues working at the young Silicon Valley startup called Intel. The first microprocessor was called the Intel 4004. The Intel 4004 processor held 2,300 transistors. It became the first general-purpose programmable processor on the market, a building block that engineers could purchase and then customize with software to perform different functions in a wide variety of electronic devices. By mid-80s, the transistor count on a single chip had already exceeded 1,000, and hence came the age of very large-scale integration, or VLSI. Very large-scale integration is the process of creating an integrated circuit, or IC, by combining thousands of transistors into a single chip. The microprocessor is a VLSI device. The electronics industry has achieved a phenomenal growth over the last few decades, mainly due to the rapid advances in the large-scale integration technologies and the system design applications. With the advent of very large-scale integrations, the number of applications of integrated circuits in high-performance computing, controls, telecommunications, image and video processing, and the consumer electronics has been rising at a very fast pace. Intel's 386, released in 1985, had 275,000 transistors and allowed the computer to work on multiple applications at the same time. Its successor, the 486, was Intel's first chip with a data cache, which stored a subset of memory on board for faster processing. After several years, AMD released its own 386 microprocessor with approximately 200,000 transistors, helping bring the competition to the industry. And in 1993, the Pentium processor debuted and had 3.1 million transistors. It used a technique called branch prediction to forecast upcoming instructions, so it could execute them more quickly. If we take a look back about the Moore's Law, this is the prediction made by an American engineer, Gordon Moore, in 1965, that the number of transistors per silicon chip doubles every year. The observation is named after Gordon Moore, the co-founder of Fairchild Semiconductor and was the CEO of Intel, whose in 1965 paper described a doubling every year in the number of components for integrated circuits, and projected this rate of growth would continue for at least another decade. As can be observed, the integration complexity doubles approximately every 1 to 2 years. As a result, memory density has increased by more than 1,000-fold since 1970. From its inception in the early 70s, the microprocessor has grown in performance and complexity at a steady and a predictable pace. This prediction, or Moore's Law, has proven to be amazingly visionary.